Hello.
Yes, sir.
Good evening. Is my voice clear?
Yes, sir.
Are you able to see this slide PPT?
Yes, sir.
Welcome to day number 16. Okay. Last class up to day number 13 we are discussed. Okay. Uh, the next day, that is tomorrow, there will be an exam for the Boolean operation exam. You already have a lot of practices right now. You can understand that Boolean methodology, and using that methodology, tomorrow there will be one exam. Along with the model, we have to create the drafting also. Okay. Okay, we will continue day number 16 now. Assembly with constraint. So this is the topic name. Hello. Hello.
Yes, sir.
This is the topic name, assembly with constraints. I skip this point because the day number is 15 regarding your exam. Okay. So this is what the assembly we need to make today. Okay. Take a screenshot of this slide.
And then, sir.
What are the challenges today? That is what the objective of today's learning. Take a note of this. Call existing component, manipulating the parts, translation, rotation, stop manipulation on clash, check degrees of freedom of assembly and its constraints, check degrees of freedom of assembly and its constraints, then assembly constraint, coincidence, contact, offset, angle, fixed, fixed together, quick constraint, change the constraint, reuse pattern. Okay, so this is our today's objective to discuss. Next point is this: replace component, duplicating parts in assembly, fast multi-instantiation, define multi-instantiation, generate numbering, explode assembly, create scenes, save all assembly, save as assembly, save management. Take a screenshot of this slide. Is it over? Hello? Hello? Hello?
Yes, sir. Done.
Okay. This is for your practice assignment. Now I shift to the software. I take here assembly from mechanical design, assembly design workbench. Give the assembly name here by right clicking option. Go to the property, select the product tab and give the assembly name. The assembly name is stuffing box. Okay. Now I will open this assembly. Now here you can see the first part is a body. That part we need to call. Okay. So to call the body on the first part, use these toolbars. So in the assembly, what are the different toolbars? Very quickly take a note of this. These are few toolbars which we require to use in assembly. Move, product structure and constraint. This is the main three toolbars. The last one is the scenes. Four toolbars are required. So in the product structure tool, first is a existing component we have to take. Just select this existing component, click on stuffing box. Okay, now the folder browser will appear. Now from that, we need to take the first part. The first part is body. This body we have to call it. Open. Second part we need to call as per this tree. This is what the bill of material actually. As per this bill of material, the neck bush is the second part. Where is that? Yes, this is the neck bush. So before going to call that neck bush, we need to check the degrees of freedom of this part. So total how many degrees of freedom present for each component in assembly? How many degrees of freedom are there for 3D part in the 3D space?
Six.
Total 6, correct. So that degrees of freedom we need to lock it using the constraints. Okay, just like the sketcher we are use the constraint to lock the degrees of freedom. Similarly for part inside the assembly we need to use the constraint to lock the degrees of freedom, and also relate the component with respect to relative location with by by use of these constraint options. Okay, so in the constraint toolbars you will find the different assembly constraints. Currently this part we are simply called it, but its degrees of freedom is not locked. So how to check it? Go to analyze here, analyze, and then take here a constraint, then constraint analysis dialog box will appear. Degrees of freedom tab will be there, and here it shows the 6 degrees of freedom. How many? 6 degrees of freedom. You can double click here, it will be show you there are 6 degrees of freedom, 3 rotation and 3 translation. So what we have to do, we need to vanish this or remove this particular degrees of freedom toolbar. That will be removed only when we use the constraint appropriately. So I'm selecting the fixed constraint and select this part. Now you can check it here, analyze constraint, degrees of freedom tab will be removed. It means your assembly is fully constrained. So this is only one method to identify your assembly is fully constrained or not. That is this degrees of freedom option. That is through constraint, analyze constraint option. The degrees of freedom tab should be removed. Then only you can consider your assembly is fully constrained. The next part is we have to call, select this existing component from here. Existing component, click on this root assembly stuffing box. The second part as per this tree is shown you, that is a neck bush. So just click on the neck bush. Where is it? Yeah, here is neck bush. Open it and move this part. Okay, so using this move tool, the first option is here, manipulation. In the manipulation tool you will find this dialog box here. This is the x direction movement. Here is a y directional movement. Then this is the z direction movement. and this is user defined direction. Suppose I'm taking this direction and then try to move this. So along that selected direction only, that part is get translated. Why it is translated? Because the degree of freedom is totally free for that direction. So I'm selecting around X, around Y, around Z axis. Okay, so this is vertical Z axis and this is user defined direction. I'm taking this one right now. So along that it will be rotated, even though you can take self axis of this component and then try to move, it will rotate. So three translation and three rotations are there. Now we need to fix that constraint. Use this option coincidence. The axis of this neck bush and this ID you have to select. Then again alignment coincidence. When you want to do alignment, use the coincidence, and if you want to use a mate option, then use a contact. So I'm taking coincidence option. This face and this face should be aligned properly, and then use here update option, update all. Okay, now you can check the degree of freedom on this. Analyze constraints. Degree of freedom is showing to you one, but which one is that pending? You can double click on it and then check the rotation is there. Okay, the rotation degree of freedom will be there, and to lock that rotation there is alternate way to check the degrees of freedom. You can right click on neck bush and use this option object, neck bush object, and use here component degrees of freedom option on. The same option will be appeared. So this is the rotation degrees of freedom we need to lock. So how to lock it? Just expand this neck, expand this bush. Here you see this different three planes, so you right click and show this. Okay, so part planes, I just active this. I don't need this XY plane. I will off it and then align this properly using coincidence option. You can use the angle option. So use the angle option now. So this plane of neck bush, that is ZX plane, and the ZX plane of body, that should be parallel, or you may take perpendicular. Anyone you can use. Currently I'm taking parallel. So two planes become parallel if you do update option. You can see here this plane and this plane become parallel. Okay, so to make the plane parallel, we need to active the first plane and then make the parallel option on. Okay, now check the degrees of freedom. That there is no tab. Okay, now the third part of it is shaft. So to insert the shaft, just click this existing component. Third part is the shaft. Open. Now you can move this part using this option manipulation. Select this X direction moment. I will on this option reframe on. Here is the shaft. It is just merged, intersected here. You just simply select this and try to move this now. Is there a shaft? Just a minute. It is hidden. That's why it's not showing. Okay. So this is shaft already there. It is hidden. That's why it is not showing. Now I can move this part along X direction, along Y direction. You can check the direction through this compass also, and around along the Z direction. Now this axis and this axis is aligned. Okay, the next part is stud number 4. This is the stud that is get fitted here. Okay, first you check here constraint is fully locked or not. I think for the shaft there are still 2 degrees of freedom, rotation and translation. Only axial alignment is there. So you try to move this part vertically, it is get moved. Okay, so here to lock this moment, we need to take contact of this face and this face. Now it will be appeared like this, but the contact I need in the reverse direction. Then I delete this contact from this constraint tool and do it again. Select here coincidence. Select this face and this face. Click on OK. Now it is not reversed. So the difference between contact and coincidence is that in the coincidence the level is aligned, and for contact that the level is that selected two surface are connected together. Okay. So when you want a surface alignment, use this coincidence, and if you want a mating or contact between two surface, use contact constraint. But I currently don't require contact and coincidence in this situation. I need to insert at specific distance. So whenever you want to insert the shaft or any component at specific distance, then you need to use this option. What is that? Offset constraint. So offset between this face, and you can say this face. So let's say that gap is minus 20, and simply update this. So at 20 mm distance, the object is inserted from this face to this face. So whenever you want to insert something or any shafts in the software, then use this option of offset constraint. Okay, now check the degree of freedom for this shaft. It will show only one, which is the rotation. And to lock the rotation, again the procedure is same. We just expand this, active this all these planes. Okay, now use this angle constraint. The angle between this plane and this face, you can take this face. That two become parallel or perpendicular right now. Currently, is it parallel or perpendicular? It is parallel or perpendicular. Hello, hello. It is parallel, na? So I'm taking here parallel option. If specific angle you want to define, let's say it's 45 degree, and then update this. Now that plane is inclined at 45 degree with respect to this face. See, if you want to delete this, you can select and delete it. Okay. So what I done here, I repeat, I delete entire shaft and do it again. Select this existing component and I include this component, but I see the component is wrongly selected. I need here shaft, but I selected here a stud. Okay, this is again access type of component, and I applied some constraint with respect to this ID. Okay, now I observe that the selected part is totally wrong. I need to fit it here shaft instead of that stud. By mistake, I'm taking the stud. Then the question is how we can replace. How we can replace this. So here is an option to replace this part. Replace component. but geometry between the different two parts become same. Topology becomes same. Size can be very different, but geometry should be the same. Okay, then only you can replace the part. So I'm selecting this replace component. Select this stud. So instead of stud, what you want, I need the shaft. Just click open. Okay, and it is asking to you, do you want to replace all instances? Say yes and click on OK. Now we can check that shaft is replaced. Okay, similar products, if I chosen by mistake and you want to replace it, then you can use this option of replace component from product structure tool. After that, we need to insert the part. Just select this constraint, offset between this face to this face, it is -20. Update, and then I need an angle. Select this plane and this face, that become parallel. Check the status now. Here it shows the broken constraint. The broken constraint means earlier parts we are deleted. Which part you are taken? Stud, and the constraint of that stud is get deleted. That's why it is showing broken constraint. See, offset, coincidence, these all are broken, so we can delete it because the parent is deleted. That's why it is shown a broken option. Okay, now you can check the status again. Constraint, degree of freedom, it's showing 2. Translation and translation 2, it means that axial alignment is still not there. So what we need to do, you simply use an axial alignment, this one and this one. Now check this constraint. Now that tab is reboot. Okay, next one. After shaft there is a stud. So we'll call this part stud. It is not showing to you because it is inserted inside this part. Then I can right click here and use this reframe on option. Still it's not showing to me. So better option is that while calling this stud, you need to use the second option of call. That is what existing component with positioning. So I'm selecting this second option. Okay, now select this stuffing box and use this stud and click OK. Now it is asking to you where you want to place this part initially, because if you use the first option by default, it is the clash with respect to the previous parts. So the parts is very small, then it is very hard to find it. So I'm selecting here more option and directly use this constraints. So I need to use a coincidence between this axis and this axis. It is aligned now directly. Okay. Now you can move this part. Now here is very important thing is that if you see, this is the different holes. If you try to expand this part, and here you see there is a pattern. Okay, these two holes instances are created inside the pattern and original hole is here. That's why I align the part with respect to the original location of hole, not with respect to axis of these instances. Okay, so the while doing the pattern inside the assembly, there is one condition is that we need to constrain the component with respect to original axis of hole, not with instances or instance axis. Okay, that's why I'm taking this axis. After that, there is one more constraint, use the contact. Now there is a backside face and this face, these two faces we need to select. After that, rotation we need to lock it. So you can expand this stud And here these are the different planes. We can on it and use this angle constraint parallel again. Okay, I can off these planes now. And now check this degrees of freedom. Still it's showing 2 degrees of freedom, translation 1 and translation 2. Okay, because the constraint of axial alignment is just we use it for the positioning purpose, not for a constraining purpose. So you simply move this part, okay, and then align it using coincidence option. This axis and this axis should be aligned. Now if you try to move this part, it will never move because all degrees of freedoms are locked right now. At any direction it will not move, but still you want to move it, then you can off this button with respect to constraint and then try to move this. It will be moved, but that moment is temporary. When you do update all, it will bring to original position again. Now you check the status from here, analyze. Okay, degree of freedom is completely locked. Now two instances we need to use. So use the pattern option from assembly, reuse pattern. But the condition of pattern is that you must have the part, there is a pattern. You must have introduced the pattern inside the part. Okay, if this pattern is not present, different holes are there, then you cannot use this option, reuse pattern. Okay, so I'm taking this reuse pattern button. Then one dialog box appeared. Select the part, which part you want to pattern it, and along with the constraint you want to use pattern. So generated constraint button on. After that, select this instances. Click on OK. Now check degrees of freedom here. No need to use constraint again. Okay. After that, next component. What is that? Stored. There is a gland and gland bush. Okay, we can do that specific sub assembly. This is the part number 4 and 5. Sorry, 5 and 6. This is the 5 number part and this is 6 number part. So these two parts I can make it separately again by using different assembly, and I call it sub assembly. This is sub assembly. Give the name sub assembly. Enter. After that, call the part. The procedure of making sub assembly is again same. First we need to call here, yeah, we need to call here the 6th number part. Sorry, first one is gland, right? So I call it first gland part. Yeah, here is a gland. Open it, and I make them fixed constraint so that all degrees of freedom will lock. Second part here is gland bush. This part you can move it anywhere right now. Okay, the axial alignment we need to create axis of this, and this should be matched. After that, as per this drawing, this top face and this face should be aligned. And the last one is that you can check here, analyze constraint. We'll find 1 degree of freedom, that is the rotation. So I'll active the planes of these two parts. Now check the degrees of freedom. It will be removed. And now I'm going to store this file. So remember, while storing this file, I'm not using save option because it will get overwrite whatever the parts I chosen. I want to store it in different folder, different location. In that situation, you know that you can use the save as functionality, right? Or even though you can use save management. So I'm selecting here save management Before that, I produce one specific folder here at the desktop location, or you'll take at your location D drive, Katia online. Here I create a folder, day number 16, and at this location we want to store my parts along with assembly. So I'll copy this path, okay, and now use this save management function. Save management. So whatever assemblies we opened in the previous windows, that all are displayed over here. But currently what assembly I need here, subassembly only, which is given this name, subassembly. It is not stored. That's why it is showing complete blank. Okay, how I choose this option from file, save management, and use this subassembly. And this subassembly we need to store at what location? Save as, paste your path here. This is day number 16. There I want to store this assembly along with its concerned parts or the components. So all supporting files, that also I need to store in the same location. That's why I use this propagate directory option. So whatever the attached parts are there, that also gets stored in the concerned location. So click on OK. Click on OK. Now we can check that Windows Explorer D drive. Here you can see day number 16. These parts are there. Only subassembly, bush, and gland. That parts are stored. Okay. The parts are stored because of propagate directory option. Then go to this window, open the previous part, stuffing box. Now here we need to call that assembly as a component that we called a subassembly. Here you see the main assembly. Now use this button existing component, click on stuffing box and take this path. D drive, Katia online, day number 16. This subassembly as a component we have to call it. So we call this part. Okay. So whatever the planes are there, I can off it all planes by selecting this plane. Okay. Now it consider as a one component. Now I'm going to move this part. Update here. Select this with respect to constraint you have to on. Now you can see it will be more like this. So there are two parts inside it, gland, bush, and gland. Okay. After that, we need to constrain it. What I need to do, I need to use insertion option. I need to insert like this. Okay. So to insert that, which command I need to use? Offset constraint. Select offset constraint. Offset between this top face and this face. Currently it shows 115. So I'm taking here minus 50. Okay. So it is at 50 distance offset distance. It is get inserted. After that you check this. It shows 3 degrees of freedom. Why? Because axial alignment is not there. You try to move this part now. Axial alignment is not there. So use this coincidence. This axis and this axis is aligned. After that, next, I think there is last rotation. Rotation is there. So we'll move this part along Z direction. To log the rotation, what can I do? I'll on the plane of this part. But if you expand the part, There are multiple planes. Okay, and that planes you can do a parallel with respect to this face, similarly which we done here in case of studs. So there is another way. You axial align this another hole, automatically that rotation will get locked. Now check why rotation is locked, because one axis is aligned here, another axis is aligned here. That's why the rotation is not possible. Okay, then I think this assembly is near to finish. The last step is that open the part and check this next step. We have to introduce the nut and check nut. So we call the nut here. Just a minute. Stuffing box. This is the part. Okay. So I call the part from this path. I need to use your nut, but see the nut is not finding to me. It is inserted at in between these parts. So what is another way? And delete this. Use this existing component with positioning option. Click here. Call this nut open and do coincidence this axis and this axis. If you activate this verified constraint or automatic constraint creation along with position and constraint also can be done, but I don't need to use a constraint. I just want to position it to this axis. Click on OK. Now again use a coincidence. This axis and this axis get aligned. Then bottom face get matched here, contacted, and for rotation take any face. This face and this face is parallel. Then update here. All three constraints at a time I provided and go to this constraint. The tab is not there. It means fully constrained. Again, multiple instances there, but currently I cannot do multiple instances using this pattern. Why? Because this nut is not directly related to the axis of hole. It is related to axis of this shaft. Just try to do it. Can off this. It shows the message. Why it shows message? Because whatever the relation we are defined, that is not with respect to axis of hole, we are relate with respect to axis of the shaft. That's why the instances we cannot generate it again. So here in this situation what we can do, I delete all constraints from constraint tool which is related to that nut. This is coincidence. I will delete this and try to move this part. Okay, even though I will hide this to take that whole axis. So use this axis and this whole axis. Now update here. How to on this hidden parts? You active this stud and just right click here and show it again. Now check the degrees of freedom. It is removed. Use this pattern now. Use pattern. This nut and instances. Which instances? This select generated constraint option on. Okay, but still it showing that It is not directly linked with the axis of hole. Okay, so in this situation there is alternate way. I go to the slide number 4. We used call existing component manipulating parts. Okay, check degrees of freedom. These constraints we have said. Replace components also we discussed. Duplicating the parts inside assembly. So this functionality we can use it right now. Fast multi-instance, define multi-instance. Okay, so if the multiple entities or multiple components we need to call, then use this functionality, parts multi-instance. So these nuts I need two times more, two times more. Okay, I cannot use right now this reuse pattern, that's why I use this option, fast multi-instantiation. Fast multi-instantiation, you can expand this and you will find these two options, fast multi-instantiation and define fast multi-instantiation. So first I'm using number one option, fast multi-instantiation. Which part? This part I need to call it multiple times. How many times it is called? Only one time. But how many required? One. There are two instances we required, so I just delete this. Okay, if you're not going to use this option, then you select this existing component, go to the stuffing box and browse your directory. Okay, and then call it. And these steps is get avoided if you use this option. There is no need to browse the parts because the parts is already present in your assembly. Okay, two quantity I needed, so I'm using this define multi-instantiation, and in this you select just like the pattern how many quantities you want. Okay, so total quantity will be 2. The spacing between each is 120. Take any one spacing along x direction, y direction or z direction. Along y direction I want, so you take y direction. Which part you want to take multiple instance, so this nut and click on OK. So the two parts are called directly. So it is the advancement of calling. It is the advancement of this calling. Here you get more effort to find your data or the to browse your data. If the data is already present in an assembly and you want to reduce your time to browse it, then use this function, define multi-instantiation. Earlier it shows only one, because in this define option only one instance is there. Okay, so you take multiple also, 4 5, how many you want it. Multiple times you can call it simultaneously and then constrain it. Constraint you cannot avoid, we need to constrain it. So we have to constrain here, contact. After that, this face and this face parallel. Again, coincidence. This is get aligned here. Contact over here. And alignment. Angular location. Okay. Parallel. Update. Alright. So this is get created. Assembly. Now check this constraint here. Still for not one, there is 1 degree of freedom, that is translation. You can check the translation vertical. Okay, so we'll move this part along z direction and constrain it. Contact this face and bottom face. Update. It is vanished. Okay, now you have to store this file. Go to the file, use save management. What is that assembly name? Stuffing box. Stuffing box. It is not stored here. stuffing box. Then use the save as where you want to store D drive, uh, online Katia, day number 16. Here I want to store only assembly is stored. Along with assembly, you want to propagate the components also supporting files. Then use propagate directory. All parts is also get stored at concerned location. Click on OK. Now you can check it through open D drive online day number 16. These are the different parts. So along with assembly, you will find subassembly and all its parts. That is the benefit of save management. Okay. Now next is generate numbering. That generate numbering is required for creating bill of material. Okay, when you use this analyze bill of material option, here you can see this is the bill of material. As per this tree, what is my requirement? First column serial number, part name and quantity. Three columns are required. So I can define it through this defined format. Okay. First I need a number, then call it. This is my first position. Just select this change order and click over here. Then I need a part, change order, click here. Then I required here quantity. This I don't need, so you can cancel out from this arrow. Revision also I don't require, even though I don't require sub assemblies data. Click on OK. The numbers are not showing to you. To generate this number over here sequentially, we need to use this command, that is the generate numbering. Okay, click on this generate numbering, click on stuffing box. You want to generate numbers or letters ABCD. So I want 1 2 3 4 numbers, so first option is on and click OK. Now you can check here bill of material, the numbers are assigned appropriately. Click on OK. So this is what the bill of material creation. So analyze bill of material using defined formats. As per your required column, you can define the formats here, and after creating the formats, you can generate the numbers. Okay, nothing will be happening in assembly, only numbers are assigned to the bill of material when you use this generate numbering option. Okay, next, explode assembly, creating scenes, and save all assembly, save as assembly, save management we already taken up. Now we go to the explode assembly. So to explode it, I first store this once again, save management. This is what stuffing box, save as stuffing box. Okay, so yes, propagate directory. Okay, so okay. After that, next, we need to explode this. I can hide this constraint. To explode the assembly, we need to create here scenes toolbar. So click on this enhance scenes, click on OK. One green background will appear. Now in this, what we have to do, make explosion as per the given drawing. So just call this compass, drag here and release here. And now by dragging this direction, you can explode like this. You have to select only this one. Select this one now. Then call this and release on this stud. Now three studs at a time we want to explode. Just select all studs by pressing Control key and then move along this direction. But what's the problem? It is get selected here. I don't want to select that. Only three parts. This is what the nut. Again, drag and drop on this stud. If you want exact distance of movement, you can double click and put here exact parameter here. Currently it's showing -75. You can take 80, 20, whatever you want. By double clicking on it, you can do define exact distance. So I can drag and release on this coordinate system. It goes to the original position now. Next one is this. Last is there. So this is what the assembly exploded format that is stored in the scenes, just like the photo. It is captured like a photo. And after that, you have to exit this enhance scenes. Just click on exit scenes button. In the application mode, you can see the scenes. So right click here and give the name of that explosion. Exploded assembly. You can take multiple explosion view in this enhance scenes. Double click on it. You can modify that also. After doing that, you have to exit this scenes from here. This is what the scenes creation. Generate numbering, explode assembly, scenes creation. Now what is save all and save as? Save as we already know about it. The same file you can store in a different name. That is what the save as. But what is the save all? You see here multiple windows are open here. You want to store everything here at concerned location. All files, not only active files. You want to store this file, stuffing box, clan bush, product 1, product 5, everything which is not showing currently in the window, but it's shown in the background window. Then that time use this save all option. Save all option. But I'm not using that intentionally because at different location. Okay. Only I store this save management current file. So which is this file? This one, save as. Yeah, here is that stuffing box. Okay. And I'll always use the propagate directory to store this supporting file to the concerned location. Okay. So this is what assembly. So in this way, we can create this explosion view separately in the drafting, and during drafting, I will show you how to do it. Okay. But bill of material setting, you have to do it on assembly. Scenes creation, you have to do it on assembly, and always use save management to store the assembly. Okay. So connect me on Google Meet. If you any doubt, we can discuss over there, and also connect it on any desk. Any desk. Allow this right now.